Is it visible? Journal दिसतंय?
Yes, ma'am.
Yes, ma'am.
Yeah, fine. So today we will learn about next type of engineering structure, which is known as cables. So you might have seen cables which are supporting some external loads, which are, you can say, high magnitude loads, and such type of cables are present in case of transmission towers, where again your cable is just like our strut members which are present in the trusses, which were slender members, means their length was very much high as compared to their cross sectional dimension. So likewise, cables are also a kind of engineering structure which supports external loads, and they play very important role in case of transmission towers also, or in case of cable bridges. So these cable structures are important. Now you know that cable, rope, string, flat belt, up till now we have seen in entire unit number 1 that all these things are supporting, or they are only analyzed or designed to carry what type of force? Cables, strings, ropes, कसा force घेतात?
Tensile force.
Tensile force.
Correct. They always take only tensile type of force, or tension can be developed in string or rope, because you know that if there will be some type of pushing force in cable segment, then from both the sides, or even from one side, if one end is suppose tied with some object, and from second end of your rope, if you will apply some pushing or pressing force, what will happen to that cable? That cable will try to have a sag, that is deflection. It is not designed to carry any kind of compression. But if you will pull that second end towards you, then definitely that string will carry tension. बरोबर का?
Yes, ma'am.
Yes. So your strings हे पक्क डोक्यात ठेवायचं. Strings, cables, ropes, okay, flat belts, or you can say belts, they will always be designed to carry tension. So now I will draw a standard shape of cable. In your syllabus you will have problems like such type of cable segments only. ते पण ऍक्च्युली तुम्ही सब्जेक्टिव्ह तर फेसच करणार नाहीये. सो in case of objective, some figure will be given to you, and it can be asked to find out tension in the or you can say maximum tension in the segment, or which cable segment will carry maximum tension. Likewise, you will have some problem in case of your MCQs. This is standard shape, you can say, of cable segment. Every single cable segment, this part is known as segment. So every single cable segment is tied with, or you can say is attached with some other cable segment, and they are forming joints. All these are the joints. Both ends, this is standard case, both ends of cable are supported by, can you tell me what type of support is this?
Hinge support.
And this one?
Hinge.
Hinge.
Both are hinge.
Hinge.
Okay. So if suppose A, B, C, D, E are the joints, at A as well as at E, we are having hinge support. Can you tell me how many reaction components hinge provides?
Two.
Two reaction components, correct? So 2 for A and 2 for B, E. बरोबर का?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
4 reaction components will be there. If I will apply some weight at B, at C, at D, and 2 reaction components at A and 2 reaction components at E, can you tell me whether I will be able to find out values of my 4 unknown reaction components by using my 3 conditions of equilibrium?
Yes, ma'am. We can find.
How can you tell me?
by using summation of fx, summation of fy,
इज
and
इट सो?
moving.
किती इक्वेशन असले की किती अननोन काढू शकतो आपण?
नाही काढता येणार.
नाही काढता येणार.
नाही जमणार.
दोन इक्वेशन असताना मी दोन अननोन काढू शकते. ऍटलिस्ट मला तरी जेवढं मॅथ्स येतं त्याच्या अकॉर्डिंगली. इफ 2 unknowns आर देअर, 2 इक्वेशन्स आर देअर, येस आय कॅन सॉल्व. If 3 unknowns are there, 3 equations are there, yes, I can solve. But I am not able to find out 4 unknowns by using 3 conditions of equilibrium. Are you able to solve it?
No, ma'am. No.
No, ma'am.
No, you cannot. Such type of structure is known as indeterminate structure. So initially, if someone will ask you whether your cable structure is a determinate or indeterminate structure, the answer is no. Cable is indeterminate structure as a whole. I am talking as a whole. Okay? But if suppose this is your end A, this is end B, end E. This is point B, I am transferring over here. This is point C. This is point D. These distances I will consider as x1, x2, x3 and x4 suppose. And if suppose any one point, any one joint B, C or D whose vertical distance with respect to level of the support which are at same level, if this vertical distance which is known as YC, because this is corresponding to point C and distance along Y direction, so I will give that name as YC, which is also known as sag of joint C. If any one point, इथे काढला असता तर मी त्याला YB म्हटलं असतं, इथे काढला असता तर मी त्याला YD म्हटलं असतं. So if suppose sag of any one point of given segment, cable segment is known with respect to your support, then yes, even if by using 3 conditions of equilibrium, I will be able to find out values of 4 unknowns. Because what I will do, I will again apply same principle which I apply to trusses. In case of trusses, what I say that if entire truss is in equilibrium, then each and every isolated part of the truss will also be in equilibrium. Barobar ka?
Yes, ma'am.
Same
Yes,
way
ma'am.
in cables also I will say that if entire cable structure is in equilibrium by application of downward forces and by support reactions, then every isolated part of the system will also be in equilibrium. And using this principle, I can find out unknown reaction components at A as well as E. आता त्याच्यासाठी जो बेसिक पार्ट थेअरीचा किंवा केबल रिलेटेड माहिती पाहिजे तो मी आता इथे एक्सप्लेन करते आहे. And then we will go to problem. Now here in this case, if you will see this cable structure, every single part of cable, that is AB, BC, CD, DE, is known as cable segment, which is connected at the joint. They are forming joints, and load is not applied on cable segment, but load is applied on joint, just like truss. Okay? Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
These weights, suppose I will name as W1, W2 and W3 are the applied weights. This is YC, sag of joint C. A will be having some support reaction and E will be having some support reaction, which will be the components because both are hinges, hinge support. Now, if I will show, I know that all these cable segments are going to carry tension. So in this case, in cable segment AB, obviously there will be some tension. Tension is shown by arrow towards each other in member. Barobar?
Yes, ma'am.
Yes, ma'am.
Okay. This is tension AB. This will be tension BC.
BC.
Every segment will carry tension only. This will be tension CD. This will be tension DE or ED. Now if I will say that entire cable segment is in equilibrium, can I say that my joint A should also be in equilibrium and my joint E should also be in equilibrium? Yes or no?
Yes, ma'am.
Yes.
Correct. Now at joint E, there is one force which is acting in the downward direction, that is arrow going away from joint A, which is representing tension in AB. Correct ka?
Yes, ma'am.
Yes.
Is it correct?
Yes, ma'am.
Yes.
Yes, ma'am.
So to balance this tension AB in such a way that my joint A must be in equilibrium, can you tell me what type of force I should apply on joint A?
In opposite direction.
Equal and opposite.
It must be collinear. Yes or no? Yes or no? It
Yes,
should
ma'am.
be
Yes.
collinear with same magnitude and opposite in direction.
Yes, ma'am.
Barobar ka?
Yes, ma'am.
So can I say that my reaction provided by hinge should be of equal magnitude with tension AB. It must be collinear with tension AB and it must have opposite direction to AB. Yes or no?
Yes, ma'am.
Yes, ma'am.
So if this is my RA, expected reaction at A, which is hinge, it is moving in which quadrant?
Second.
In which quadrant?
Second quadrant.
Second quadrant. So what should be direction of my HA and VA? Is it correct?
Yes, ma'am. Yes.
Yes, ma'am.
समजलं सगळ्यांना?
हो, ma'am.
Okay. Same way for joint E. Only tension DE is there. To keep this joint E in equilibrium, reaction provided by hinge must be collinear of equal magnitude and opposite in direction. I will call it as RE. So this is your total reaction provided by the hinge, which is moving in the first quadrant. So by default, I must have my HE component in the rightward direction and my VE component in the upward direction. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes,
हे
ma'am.
सगळ्यांना समजलं? इथपर्यंत
हो,
कोणाला
ma'am.
काही डाऊट नाहीये? कन्सेप्ट
No,
सगळे
ma'am.
समजून घ्या, कारण तुम्हाला केबल्स मध्ये खूप मोठं लेंदी प्रॉब्लेम कोणीही एमसीक्यूज मध्ये विचारू शकत नाही. बट मी हे आता तुम्हाला जे काय सांगते, ईच अँड एव्हरी कन्सेप्ट यू कॅन कन्सिडर ॲज एमसीक्यू. आतापर्यंत मी काय काय एमसीक्यू सांगितले? एव्हरी केबल सेगमेंट विल कॅरी टेन्शन ओनली. Your tension in last segment, it can be left last, it can be right last segment. Whatever will be the reaction, total reaction provided by hinge will be collinear of equal magnitude and opposite in direction with your left segment, and for this it will be for right segment. Is it clear to all?
Yes, ma'am. Yes.
हे
Yes, ma'am.
सगळे स्टेटमेंट तुम्हाला एमसीक्यू मध्ये कन्व्हर्ट करून विचारू शकतात. डन? इथपर्यंत समजलं सगळ्यांना? चलू पुढे.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes.
So this is my, now I will not draw that RA, okay, which is going to balance your TAB. Now I will just show you HA leftward, VA upward. This is my free body diagram. Here HE will be rightward and VE will be upward. Is it clear to all?
Yes, ma'am.
Yes, ma'am. Yes.
Done. Now if I will apply conditions of equilibrium to entire truss, my equation of summation fx will give me HA is equal to HE. Yes or no?
Yes, ma'am. Yes. Yes, ma'am.
Because only horizontal component or only horizontal force present in the structure is horizontal component at this hinge and horizontal component at this hinge. So it will be HA is equal to HE. my summation Fy equation will give me equals to 0. It will give me Va plus Ve is equal to all my W's, correct?
Yes, ma'am.
Yes, ma'am. Yes.
And my third equation of movement, now I have choice because both supports are hinge supports, correct? So if I will apply condition of movement, what I will get? I will get about A I can take, or even about E I can take, is equal to 0. If I will take about A, I will get value of VE, yes or no? बरोबर का?
Yes, ma'am.
If I will take movement about this point, I will not be able to find out value of HE, because if I will extend line of action of HE, it is passing through point A itself. So the only unknown will be VE, which will make anti-clockwise rotation. बरोबर? Rest are known to me. W1 is known, X1 is known, it will create clockwise rotational effect. W2 is known, its movement arm X1 plus X2 is known, again clockwise effect. W3 into X1 plus X2 plus X3, again clockwise effect. The only anti-clockwise effect will be of VE, that is VE into X1 plus X2 plus X3 plus X4. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
हे समजलं सगळ्यांना? At the same time, if I will take movement about instead of A, if I will take about E, then in that case I will get value of, instead of VE, I will get VA. बरोबर का?
Yes, ma'am.
Yes.
Okay. So any one value if I will get, obviously I will put that value in equation number 2, and I will be able to find out second vertical reaction. VE असेल तर VA मिळेल, इथे VA काढला असेल तर VE मिळेल. But yes, this first equation will remain as it is. बरोबर?
Yes, ma'am.
Yes, ma'am.
Okay. So by using conditions of equilibrium to entire cable segment, I am not able to find out horizontal components of my reactions at hinges A as well as E. Yes, vertical component I will get, but horizontal I will not get. याच्यासाठी काय गिव्हन असतं, यालाच आपण म्हणतो दिस इज इनडिटर्मिनेट स्ट्रक्चर. Because using my conditions of equilibrium, I am not able to find out all 4 unknowns. I have calculated VA, I have calculated VE, but I am not able to find out HA or HE. Yes, I can say that HA is equal to HE, but value I don't get by using my 3 conditions of equilibrium. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
सगळ्यांना समजलं?
Yes, ma'am.
Yes. Now this YC or this sag is given for calculation of HA or HE. What I will do, just like trusses मध्ये जसं section method वापरली होती, just like that, in this case also we will cut this entire cable segment from point C vertically. असा vertically कट देणार मी त्याला. बघा बरं काय येईल. या सीच्या जस्ट राईट साइडला मी कट दिला, समजा इकडे जाणाऱ्या CD सेगमेंटला मी कट दिला. सो आय विल गेट दिस ॲज W2, दिस ॲज W1, दिस ॲज HA, this as VA, this is up to this distance X1, this remaining is X2, this perpendicular is YC. बरोबर का?
Yes, ma'am.
काढली का मी diagram?
Yes, ma'am.
Okay. Now if I will consider this part, if I will cut this part from my parent cable section or entire cable segment, as I say that entire cable segment is in equilibrium, I can also say that isolated part of it must be in equilibrium. So now can I take movement of all the forces about C is equal to 0? Can I say this?
Yes, ma'am. Yes.
Yes.
Yes, I can say. So what I will get? I will get equation. आता मी इथे मात्र equation लिहून दाखवते. Movement about C. Your W2 is passing through point C itself, so its movement will be 0. Your W1 is at distance of x2 meter with respect to C. It is going to create anti-clockwise rotational effect. So minus sign W1 into perpendicular distance is x2. इथपर्यंत सगळ्यांना समजलं?
Yes, ma'am.
Next is your vertically upward VA about point C. It will create clockwise rotational effect with perpendicular distance of x1 plus x2. So I will write it with plus sign, plus VA into x1 plus x2. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
And your HA is moving in the leftward direction. If I will take it over here with leftward sign about point C, it will create anti-clockwise rotational effect. So again with minus sign I will write, it will be HA into, what is perpendicular distance of HA with respect to
YC.
C?
YC.
YC, that is sag at point C. It must be equal to 0. आता जर मला YC माहिती आहे, x1 माहिती आहे, x2 माहिती आहे आणि W1 पण माहिती आहे, VA पण माहिती आहे, ऑलरेडी मी काढला. Can I find out HA?
Yes, ma'am.
Yes, ma'am. Yes.
I will get value of HA, which is nothing but HE. बरोबर का?
Yes, ma'am. Yes.
For this purpose, YC is given in the problem. So even if it is indeterminate structure as a whole, because when for entire structure I am applying conditions of equilibrium, I am not able to find out horizontal components at both the hinges. But when I will isolate some part from my parent truss, in that case, by using this value of sag, I am able to find out what will be that horizontal component of reaction. Is it clear?
Yes, ma'am.
Done?
Yes, ma'am.
आता मला सांगा माझ्या जो रिएक्शनच्या कुठल्या व्हॅल्यू आहेत? नाउ आय हॅव HA, आय हॅव व्हॅल्यू ऑफ VA, आय हॅव HE, आय हॅव VE. बरोबर का?
Yes, ma'am.
So can I calculate R, A, R, E, theta,
Yes, ma'am.
A, theta, E. काढू शकते मी या व्हॅल्यूज?
Yes, ma'am.
Oh, ma'am.
Yes. Once I will get to know these values, this is nothing but my reaction RE with angle theta E, my reaction RA with angle theta A. बरोबर?
Yes, ma'am. Ma'am, TAB आणि TD ही पण निघून जाईल ना?
Yes, beta. Once I will get value of RA, I can say that it is equal to tension AB. Once I will get value of RE, I can say that it is nothing but tension DE. Is it clear?
Yes, ma'am.
Whatever
ma'am.
theta A over here, same will be theta over here, theta A. Whatever will be theta E over here, same will be this angle theta E. बरोबर का?
Yes, ma'am. Yes.
Yes. Afterwards, what I will do? I will now isolate joint B. If I will isolate joint B, I know that as entire cable segment is in equilibrium, it is also in equilibrium. Can you tell me how many forces are acting on joint B? How many forces are keeping joint B in equilibrium?
Three forces.
Three forces.
Three forces.
Forces. Which theorem we can apply for equilibrium of three forces?
Lamis theorem.
Lamis theorem.
Theorem. Correct? So can I isolate my joint B so that this will be tension AB, this will be tension BC, and this is W1. All are moving away from the joint.
Yes, ma'am.
Barobar?
Yes, ma'am.
Yes. So if I know any one force, now here I know W1, here I know tension AB. So by knowing angle, can I find out tension AB?
Yes, ma'am. Yes.
Yes, ma'am.
Same way on joint C, if I will isolate C ने D. D बघा किती फोर्सेस मुळे इक्विलिब्रियम मध्ये आहे.
3 forces.
अगेन
forces.
डाउनवर्ड
Three forces.
tension CD, tension DE. I know this tension DE. I know its angle with respect to horizontal. This is W3 which is downward. So if I will draw free body diagram of this D, it will have tension DE, tension CD and W3. Can I solve it again either by Lami's theorem, or if some angles or something is missing, I can even use summation fx is 0 and summation fy is 0.
Yes, ma'am.
बरोबर का?
Yes.
So your analysis is nothing but finding out tension in all the cable segments. So by using this method, you will be able to find out one by one tension in all the cables. आता हा असतो तुमचा सब्जेक्टिव्ह प्रॉब्लेम. जेव्हा तुम्हाला 6 मार्कांसाठी प्रॉब्लेम विचारतात केबलचं, तेव्हा तुम्हाला हे सगळं करायचं असतं. बट आपला एमसीक्यू तर 2 मार्कांचा असेल ऍट द मॅक्स. बरोबर ना?
Yes, ma'am.
Yes,
मग
ma'am.
आपली जर फायनल एक्झाम असेल, जेव्हा एंड टर्म एक्झाम, तेव्हा तो 3 मार्कांसाठी असेल. मग एवढं मोठं सगळं लेंदी विचारतील का ते आपल्याला? नो.
No, ma'am.
सध्या तरी निदान मिड टर्म एक्झाम साठी किंवा आईसाठी सांगते, जस्ट गो विथ ऑल दीज बेसिक कन्सेप्ट. आधी तर हे सगळे बेसिक कन्सेप्ट समजून घ्या. इकडची जी काय रिॲक्शन असेल त्यालाच कोलिनियर, इक्विव्हॅलंट आणि अपोजिट डायरेक्शनल इथलं टेन्शन असेल. आता मला एक सांगा, फक्त एकच इम्पॉर्टंट कन्सेप्ट जी की तुम्हाला परत नेहमी एमसीक्यूज मध्ये विचारल्या जाते. इफ सपोज दिस इज RA, this is VA, this is HA, and at same level, this is HE, this is VE, and this is my RE. If I will say HA is equal to HE, and if I say that this is my tension AB and this is my tension DE, can you tell me if horizontal component of both the reaction is equal, on what basis I can decide which reaction will be more?
Vertical component.
Vertical component.
I will compare VA and VE. Yes or no?
Yes.
Yes, ma'am.
Yes, ma'am. Yes.
Because this is for sure, as both the supports are at equal level, their horizontal components are balancing each other. So the only comparable parameter is vertical component of both the reactions, जो तो मला पहिल्याच मुवमेंटच्या इक्वेशन मधनं मिळाला, हो की नाही?
Yes, ma'am.
Yes, ma'am.
बरोबर? So once I will get value of VA and VE, depending on this magnitude, if VA is more than VE, I can directly say that RA will be more than RE. I need not to calculate what is value of HA and HE or काय जे काय असेल ते. मी जाणारच नाही तिथपर्यंत. हे मी एमसीक्यू साठी सांगते हा, शॉर्टकट. कळतंय का काय सांगितलं?
Yes, ma'am.
आणि मी जर म्हणते की माझा RA मोर आहे, VA मोर असल्यामुळे RA जर जास्त आहे RE पेक्षा, तर माझं कुठलं टेन्शन जास्त झालं सांगा बरं? दोन पैकी
TAB.
TAB will be greater.
ऑब्विसली TAB विल बी ग्रेटर. बरोबर का?
Yes, ma'am.
Yes, ma'am.
So just by calculating vertical component of my reaction by applying equation of movement to entire cable segment, I can judge, I can guess which cable segment will carry maximum tension Always remember that your intermediate cable segment never carry maximum tension. तुम्हाला केबल सेगमेंट असा काहीही दिलेला असला तरी तुमचे हे इकडचे केबल सेगमेंट कधी मॅक्सिमम टेन्शन कॅरी करत नसतात. मॅक्सिमम टेन्शन तुमचं या केबल सेगमेंट आणि या केबल सेगमेंट पैकी एकात येतं. हे नेहमी लक्षात ठेवा. आणि या दोघा केबल सेगमेंट मधलं टेन्शन कम्पेअर करायला one single parameter is sufficient, that is vertical component of reaction. Just find out what is relation between these two vertical components. If this is more, then definitely this reaction will be more, means this tension will be more. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes.
सगळ्यांना समजेल, लक्षात राहिली गोष्ट. दिस इज व्हेरी व्हेरी इम्पॉर्टंट पॅरामीटर. नेक्स्ट इम्पॉर्टंट थिंग फॉर केबल इज, समजा आता या रिएक्शन कंपोनंटच्या व्हॅल्यूज काढल्या नाही आपण, तुम्हाला फक्त असं काहीतरी दिलंय. इफ इट इज गिवन दॅट दिस इज सम केबल सेगमेंट अँड इफ सपोज सम वर्टिकल डिस्टन्सेस, consider kara, in this case your ends are not at same level. This is suppose over here and this is somewhere here. Now even if HA is equal to HE, but I don't want to calculate those values, I don't want to comment on it according to magnitudes of this HA and HE. What is next parameter? If this is my vertical distance which is given, if these horizontal distances are given, can I find out angle, their respective angle?
Yes, ma'am. Yes.
Yes, ma'am.
If suppose this is θ1, इथला θ2 घेतला, इथला θ3 घेतला, θ4 घेतला, हा इथला θ4 आहे. सब can you tell me, according to θ1 and θ4, can I guess which cable segment will carry more tension? If there is some relation between θ1 and θ4, कुठला मोर असेल तर कशातलं टेन्शन जास्त असेल सांगू शकता मला? काही रिलेशन आहे का व्हॅल्यू ऑफ θ1 and θ4 मध्ये? I am not able to find out this horizontal component, vertical component. मी याच्या कशाच्याच काहीच मॅग्निट्यूड काढत नाहीये. Now I am talking about only angles. Can I say that if θ1 is more than θ4, that is angle of cable segment with respect to horizontal is more, then my tension in AB will be more as compared to tension in DE. Can I say this?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am. Yes, ma'am.
Yes. It is always relative to your angle theta of that segment with respect to horizontal. As your theta increases, it means that it's theta increase होतोय म्हणजे तुमचा केबल सेगमेंट अजून अजून व्हर्टिकल होत चाललाय. याची मॅक्सिमम व्हॅल्यू केव्हा असेल? जेव्हा तो एक्झॅक्टली व्हर्टिकल असेल. इज इट क्लिअर?
Yes, ma'am. Yes.
Yes, ma'am.
Okay. So as your theta increases, your cable segment will have more and more tension. So always find out relation between these last angles. Which last segment is having more angle with respect to your horizontal? That segment will carry maximum tension. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Okay, because as you move towards 90 degree, what happens to sin 90?
1 sin 90.
1 means maximum value कडे तुम्ही जाता जसे जसे तुम्ही अँगल विथ रिस्पेक्ट टू हॉरिझॉन्टल वाढवता. इज इट क्लिअर?
Yes, ma'am.
हे समजलं का सगळ्यांना? दिस
Yes,
कॅन
ma'am.
ऑल्सो बी इम्पॉर्टंट एक्सिक्यू. हवं तर एक स्टेटमेंट लिहून घ्या. द केबल सेगमेंट which is having the cable segment which is having more angle with respect to horizontal will carry maximum tension. Is it clear to all?
Yes, ma'am.
सगळ्यांना हे समजलं का?
Yes, ma'am.
Yes, ma'am.
Okay. चलो, I will give you one problem. हे मी तुम्हाला सगळ्या क्युम्युलेटिव्ह एकदा मी या फर्स्ट जी आपली ओरिजिनल फाईल होती ना त्यातच सगळं सेव्ह करत जाते, कालचं शिकवलेलं वगैरे सगळंच. सो मी तुम्हाला ही अख्खी फाईल परत एकदा थोडंसं पुढे सरकलं की अपलोड करते. ठीक आहे?
ओके ओके मॅम.
येस, सेम फाईल आय विल अपलोड.
मॅम तुम्ही ते क्लासरूम मध्ये नंतर अपडेट पण करू शकतात मॅम, म्हणजे जे
मी
तुम्ही
तेच म्हणते बेटा, त्याच फाईल्स मी अपडेट करेल, जुनी रिमूव्ह करेल वाटलं तर आणि ही अपलोड करेल.
येस मॅम, असं केलं तरी चालेल.
ठीक आहे? किंवा मग युनिट 2 म्हणून जेव्हा अपलोड करेल तेव्हा त्यात युनिट 1 आणि 2 अशा दोन्ही नोट्स असतील.
हा ओके
असं
मॅम.
करत मी अपलोड करत चालेल.
ओके मॅम.
कारण मी तुमच्या डिव्हिजन साठी हीच फाईल कंटिन्यू करते आता. चला, देऊ प्रॉब्लेम.
येस मॅम.
Yes, ma'am.
Yes, ma'am.
ड्रॉ दिस फिगर. आणि मी आत्ता जी काढली होती ती स्टँडर्ड केबल होती. प्रत्येक वेळी तशीच असेल केबलची फिगर आणि तसंच असेल असं काही गरजेचं नाहीये. तेवढेच सेगमेंट असतील असंही नाहीये. नंबर ऑफ सेगमेंट कमी पण असतील कधी कधी. आता मी हे डिस्टन्सेस खाली देते.
मॅम ते डिस्टन्स वाय बी आहे का?
हो बेटा. हे काढताना माझ्याकडनं फार प्रपोर्शनेट नाही झालं. हा 1 मीटर आहे पण इकडचा 0.5 मीटर आहे. ठीक आहे? कॅन आय डिक्टेट? त्यातलं मॅक्सिमम जे गिवन डेटा यू नीड नॉट टू रीराइट इट. ओके, आय विल जस्ट read the word problem. It is cable ABCD supports 4 kilonewton and 6 kilonewton loads at point B and C as shown in figure. Determine maximum tension in cable and sag at B, point B. सगळ्यांना प्रॉब्लेम समजलं?
Yes, ma'am.
आता वेळ कमी आपल्याकडे, आपण फास्ट सॉल्व्ह करूया. it will be summation fx is equal to 0 will give you. Now this cable segment, obviously to carry this tension, it will have horizontal and vertically upward support reactions HA, VA. Here it will be rightward and upward to balance this cable segment, that is VD and HD. So first equation will be HA will be equals to HD. Second equation will be summation Fy will give you what you can say, it is VA plus VD is equal to 10. बरोबर का?
Yes, ma'am.
Okay.
Yes, ma'am.
Now I will take suppose movement about A. आपली रेग्युलर लेफ्ट हँडला आपल्याला सोपं जातं म्हणून आपण लेफ्ट हँडला घेऊ. Movement about A. It will give me HAVA and HD passing through point A itself. So all will create zero movement. 4 into 1 plus 6 into 4 minus VD into 4.5 is equal to 0. सगळ्यांना इक्वेशन समजलं?
Yes, ma'am.
This is
Yes, ma'am.
4 into 1. This is 6 into 1 plus 3, that is 4. Doni clockwise and VD anti-clockwise. So minus VD into total distance is 1 plus 3 plus 0.5, that is 4.5. Can you tell me what value you are getting for?
Ma'am, 3.2. 3.2.
3.2 kilonewton. Putting this value in equation number, suppose I will give this as 2. This is 1. So 2 मध्ये put केल्यावर काय येईल आपलं?
6.8.
Yes. Now can you tell me what we can do to find out?
Take moment about D. So you will get YB. No, YB. No, ma'am.
सांगा सांगा जरा विचार करा, सांगा मला. कशाचा सॅग माहिती आहे मला सांगा, तो पॉइंट आपण पहिले वापरतो. सीचा सॅग माहिती आहे की नाही?
Yes, ma'am. Yes.
बरोबर का? So can I isolate this much part? Only C to D. HD is not known to me, but VD मी आत्ताच काढला.
मॅम मला VD 6.2 आला.
Ma'am, VD is 6.22.
Yes, ma'am. 6.2.
6.2.
आणि HD
6.22 येत आहे मॅम.
मग हा 3.8 यायला पाहिजे. जर हा 6.2 आला तर तो
Yes, ma'am. Yes.
3.8 यायला पाहिजे आणि 6.2 आहे.
किती आला
3.7.
मग? सांगा मला जरा
6.2.
एकदा.
VD equals to 6.2.
6.2 आणि 3.8.
आणि
Yes.
VA
3.8.
8 और 7 8 येईल मग आता हा.
मॅम
जर
मॅम
two-
नाही मॅम VD
मॅम
VD 6.22.
VD 6.22.
अच्छा VD
6.22.
6.22
हा.
आणि मग VA 3.78
Yes, ma'am.
7, 8.
8.
7 यायला
7, 8.
पाहिजे. तर हा 2 असेल तर.
Okay.
येत आहे बरोबर?
Yes, ma'am. Yes,
Yes, ma'am.
Okay. Now to get value of HD, can I take this section at CC? Section at C. This is 6 kilonewton. Take movement about C. This vertical is 2 meter and this horizontal is 0.5 meter. बरोबर का?
Yes, ma'am. Yes.
Yes, ma'am.
Okay. Yes. So what I will get? About point C, if I will take movement, 6 will pass through point C, so movement will be 0. Upward VD, which is 6.22, will create anti-clockwise rotation about point C. With minus sign, I will write 6.22 into perpendicular distance of 0.5. and your HD will have perpendicular distance of 2 meter. As it is rightward, it will create clockwise rotational effect about point C. So can I say that plus HD into 2 is equal to 0? Can I say this?
Yes, ma'am.
Equation समजले का सगळ्यांना? Please tell me.
Yes, ma'am.
Okay. So what value of HD you will get? Can you please tell? Which will be
1.55.
1.55.
1.5.
1.5.
1.5.
1.55 kilonewton. आलं सगळ्यांचा आन्सर?
Yes.
Yes, ma'am.
Same will be my HA also. जो काय HD येईल तोच माझा HA येईल. Now these are the values of VA and VD and this is value of HA and HE. हे एवढं मिळाल्यावरच मला सांगता आलं पाहिजे केबल सेगमेंट कुठला मॅक्सिमम टेन्शन कॅरी करणार आहे.
D, ma'am. D. VD.
Reading.
VD म्हटल्यावर ऑब्विसली या राईट साइडचा
Right side.
इकडचा CD बरोबर का?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
This will be T max. But to calculate त्यांनी म्हटलंय डिटरमाइन मॅक्सिमम टेन्शन. केबल सेगमेंट नाही विचारलाय, फक्त ते मॅक्सिमम टेन्शन पण काढायला लावलंय. सो कॅन यू फाइंड आउट रिएक्शन ऍट D बाय युझिंग VD अँड HD?
Resultant काढायचं ना आणि त्याचं VD आणि
येस, रिझल्टंट काढायचा.
Yes, ma'am.
RD काढायचा. RD will be equals to under root of VD square plus HD square. Tell me what resultant you are getting.
I'm 6.41.
Are you getting this value?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, this is your tension maximum. And as I am having VA and HA, can I find out angle theta?
Yes, ma'am. VD divided by HD.
It will
Yes,
be
ma'am.
tan inverse of, if I will call it as theta A, it will be tan inverse of VA by HA.
V by HA.
सांगा मला किती येतो?
76, ma'am. 76 degree.
Are you getting 76 degree? All of you? For this VA and this HA. का बरं काढलं मी theta? Can you tell me?
ज्याचा अँगल जास्त राहील.
अँगल जास्तचा आता आपल्याला प्रश्नच नाही बेटा. इथे आपला VA जास्त आलं म्हटल्यावर आपला इथला आपण लगेच डिक्लेअरच करून टाकलं. मला काढायचा आहे हा YB, म्हणून मी हा थीटा काढतेय. This
Okay.
will be theta A. So obviously same theta A will be, this will be theta A, yes or no?
Yes, ma'am.
Yes,
Yes,
बरोबर.
Yes, ma'am.
आणि थीटा ए जर मला एकदा कळला, तो किती आला तुझा आता? 70 किती?
67.3.
67.7.
7.7.
67.7.
VD वाला काढला होता. VD वाला
घाई करू नका, घाई करू नका. जे विचारलं ते नीट व्हॅल्यूज काढा. हे सगळ्यांचे येत आहे आन्सर 67.7 डिग्री.
Yes, ma'am.
So whatever will be theta over here, same as this RA will be collinear with your this segment. Obviously, this will also be theta A. So can I say that tan inverse of theta A will be YB by 1, opposite by adjacent?
Yes.
Yes, ma'am. Yes.
So it will be tan theta A is nothing but opposite by adjacent. मला जर थीटा ए मिळाला तर मी त्याचा टॅन आणि हा 1 वापरून YB काढू शकते का?
Yes, ma'am. Yes.
येस, काढू शकते. सांगा मला YB किती येतो?
2.428.
व्हेरी करेक्ट.
Yes, ma'am.
So my YB will be equals to 2.428 meters. Are you getting this value? All of you?
Yes, ma'am. Yes.
Yes, ma'am.
सगळ्यांना प्रॉब्लेम समजलं का केबलचं?
Yes, ma'am.
Yes, ma'am. Yes.
केबलची सगळी कन्सेप्ट क्लिअर झाली? काय असतं केबल सेगमेंट मध्ये?
Yes, ma'am.
Okay, so for your practice again, along with method of section, method of joint, केबलचे पण प्रॉब्लेम मी ऍड करेल. वाटलं तर आपण पुढच्या लेक्चरला अजून एखादा केबलचा प्रॉब्लेम घेऊया. अँड आफ्टर दॅट वी विल स्टार्ट आयदर विथ फ्रिक्शन ऑर विथ स्पेस फोर्सेस. इज इट क्लिअर?
येस मॅम.
Yes,
ओके
ma'am.
मॅम.
आज मी तुम्हाला केबलची जेवढी थेअरी सांगितली तेवढी फक्त नीट समजून घ्या. If this theory is clear to you, your concept, your basic concept is clear, any problem of cable you can solve. त्या वेगळं काहीच कन्सेप्ट नाहीये त्याच्यात. एकदा फक्त तुम्हाला कन्सेप्च्युअली केबल कळली पाहिजे काय असतं. हॉरिझॉन्टल व्हर्टिकल कंपोनंटचं काय रिलेशन आहे, थीटा आणि मॅक्सिमम टेन्शन मध्ये काय रिलेशन आहे, रिॲक्शन आणि टेन्शन यांच्यात काय रिलेशन आहे, हे जर सगळं माहिती असेल तर यू कॅन सॉल्व्ह एनी प्रॉब्लेम. ठीक है, डन.
येस मॅम.
ओके, चलो गिव मी अटेंडन्स नाउ. काय रे बाबा, आज पण मला 2 अब्सेंट दिसतोय, का असं होतंय?
मॅम
ओके, वेट अ मिनिट, जस्ट गिव मी 1 मिनिट.